All right, let's get started with some of those problems that you were challenged by. The first one here, it says use similar triangles to solve. So always read the instructions. Use similar triangles to solve. An airplane ascends 300 feet at a constant rate as it flies a horizontal distance of 1,000 feet. How much altitude in feet will it gain as it flies a horizontal distance of 1 mile? And it gave us a hint that 1 mile equals 5,280 feet. So since we know we're using similar triangles, you probably know that we're using proportions. So we need to figure out, based on this question and this diagram, this image here, what are they saying? So notice here that they have this part highlighted. Do y'all see this part? So they have a small triangle, right? They have the smaller triangle and they have a larger similar triangle. So a small to large triangle. So let's look at this again. An airplane ascends, and it's important that you also look up words. What does ascend mean? So look that up. Also, altitude. What does that mean? That means height, right? So if you don't know what those words mean, this question can really throw you off. All right, so an airplane ascends 300 feet. Here we go here. This is the 300. At a constant rate as it flies a horizontal distance of 1,000 feet. So I already know we have 300 feet over 1,000 feet. That's the smaller triangle. And now what they want to know is how much altitude. That's the height again. So that would be here. If that's the height, then and this was the height, then I need to put that x feet on the same level as that 300 feet. So x feet, because that's what I want to know. And it says, how much altitude will it gain as it flies a horizontal distance of 1 mile? So this, and it's showing you here, this whole entire horizontal line here represents 1 mile. Now everything else was in feet. Now it wouldn't make sense to put 1 mile here. It would not make sense. So that's why they gave you the hint that 1 mile equals 5,280 feet. Because everything else, notice, we have in feet, right? So we need to make sure that everything is aligned to feet. All right, and from this point forward, we're solving for x, of course. So you could do what I call that butterfly and just multiply the 300, right, times the 5,280 equals, and now we're going to multiply this 1,000 times this x, which is just 1,000x. Now on the left side, what is 300 times 5,280? All right, 1,584,000 equals 1,000x, and we're solving for x, of course, so we're going to divide by 1,000. That cancels. X equals 1,584 feet. Always use the unit. So all it's saying is this right here. This was 300, but as it travels 5,280 feet this way, the height would be 1,584 feet. All right, let's move on. To the next problem, we're going to solve, and by the way, that was 6.6 number 7 if you want to refer to it in your homework. So that was 6.6 number 7. Next, we're going to go to problem in 10.2. Number 12, solve x squared over 2 plus 5 over 2 x equals -1. So we're solving equations with fractions. So always get rid of these fractions if you are solving an equation. So get rid of fractions when solving equations. So I would advise that you do that immediately. Don't go into working the problem out or the equation out without getting rid of the fractions. Alright, so notice that the LCD is 2. So we're going to multiply both sides by 2. And we're going to get, notice if we distribute on this side, if we multiply 2 times x squared over 2, what will cancel out? The 2's will cancel. I'm not going to cancel it or you'll think that the 2's are gone. This 2 will always be here, right? I'm just saying if we multiply this 2 times x squared over 2, the 2's will cancel. You have x squared. But we also have to, don't forget, we have to multiply the 2 times 5/2 x. And if you multiply the 2 times 5/2 x, the 2's will cancel out there, leaving you with a 5x. And on the right side, we have 2 times -1, which is -2. Anytime you see a quadratic forming, and over here we see a quadratic forming, right? We see that x squared. Just pull everything over to the left side. So there are 4 steps to that. Make sure everything is on one side. Set equal to 0, right? So we would need to add the 2 to both sides. So let's x squared plus 5x plus 2 equals 0. Next, normally the next step is to factor if we had a factorable situation, but this is not factorable. So we cannot solve this quadratic equation using the method of factoring. We have to choose another method to solve this quadratic equation. Thankfully, there are many other methods to solve quadratic equations. One being the quadratic formula. Another one, for example, being completing the square. But you were definitely introduced to the quadratic formula in this class, so we will go through that. So what is the quadratic formula? Hopefully you all know that by heart by now, but I will write it down. So just commit it to memory. X equals -b plus or minus square root b squared minus 4ac all over 2a. All right, so there was even a story that I put in one of the weekly assignments folder that goes along with the quadratic formula that could possibly help you memorize that formula. Now, so we need to identify what a equals. A is 1 because 1 is understood to be in front of the x squared. B is 5 since it is the coefficient of x. And C represents our constant. Since it's positive 2, C is positive 2. Now we're going to substitute those values into our quadratic formula. So we have -5 plus or minus the square root. B squared would be 5 squared minus 4 times A, which is 1, times C, which is 2, all divided by 2 times 1. All right. I'm going to put equal here. Always put equal in between your equations and your simplification. Now we have -5 plus or minus 5 squared is 25. And we have minus 4 times 1 is 4. 4 times 2 is 8. Divided by 2. All right, I'm going to go over here. That's -5 plus or minus. What is 25 minus 8? That's 17 divided by 2. And Website obviously does not have a plus or minus symbol. You have to write out the solutions separately, and you separate them by a comma. So I know I get that question every semester, but no, there's no plus or minus symbol in Website. So one solution is -5 plus the square root of 17 over 2. And let's call the other one x sub 2. Negative 5 minus the square root of 17 over 2. All right, let's move on to the next problem. All right, let's go ahead and tackle this proper dosage problem. This one right here, and I'm going to blow this up a little bit more. All right, it reads, use an equation to solve. It says the proper dose of a certain antibiotic in children is 0.025 gram per kilogram of body mass. Find the mass of a child receiving a 1 1/4 gram dose. So this problem can be confusing sometimes to people. And this is number 5, as you can see, section 6.7. 6.7, number 5. So use an equation to solve. Again, the proper dose of a certain antibiotic in children is 0.0, and a lot of times we use proportions, gram, and it says per. So per kilogram. What does per kilogram mean? 1 kilogram. And then it says kilogram of body mass. Find the mass of a child, and notice that the mass, body mass, went with the kilograms, which I put on the bottom. You may have yours in the numerator. Just make sure you keep your kilogram of body mass in the numerator if you put it in the numerator. I put mine in the denominator here. So if we're trying to find the mass, we don't know what it is, obviously, right, yet. So we use an x, right, because it's asking us to determine the mass of a child receiving a 1 1/4 gram. And notice my grams are on the same level. I have both of them in the numerator. So if you had grams on the denominator, you keep your grams on the denominator, for example. Now it would make sense that I have a decimal here, but I have a fraction here. So I think it's best to change your fraction to a decimal, right? So let me simplify this. It will end up being 0.025 over 1, and take out everything else. And what is 1/4? So you need to understand what is 1/4. I cook a lot, and we use a lot of fractions. So it's important, especially if you want to follow recipes well, that you understand fractions. And 1 1/4 is simply 1.25 over x. All right. So now we just do our little butterfly method here. That's 0.025x equals 1.25 times 1, which is 1.25. We're just going to divide by 0.025. That cancels. And when you divide that, you get x equals, and give us 50, right? If you divide that, 50. And so just 1 kilograms. Notice the kilograms was at the bottom. And I think that kind of throws you all off, because they're talking about kilograms, and I think we're kind of used to pounds and things like that. So I can see how that could be confusing. Let's move on to our next challenging problem. This is 6.2, number 19, x squared minus x minus 20 over 2x squared plus 14x plus 24 divided by x squared minus 36 over 2x squared plus 18x plus 36. So already we need to keep, change, flip. It's best for you to really just go ahead and do that. The best practice is to go ahead and rewrite everything and keep, change, flip. To save time, I'm not going to do that. I'm going to go straight into factoring. All right, so I know that we're going to end up factoring that. And I know that this is actually gonna, when we flip it, is gonna end up being here. End up being in the bottom. So I know that's x plus 6 times x minus 6 because we have a difference of squares. I already go ahead and, if I know how to factor one of those easily, I go ahead and put it there so I know that I need to flip it once I get there. Right, it's already flipped. I'm good. If you don't do that, you may forget that you haven't flipped it. All right, so let's go back to x squared minus x minus 20. Easy case, so I know that's going to be x times x. I need factors of negative 20 that add to negative 1. I know 5 and 4 will give me that 20, and I know if I make them 5 negative and a 4 positive, that's going to give me that negative 1 in the middle right here. All right, so let's move on to 2x squared plus 14x plus 24. I notice immediately all of those numbers are even, so I know I can divide by 2. So I'm going to take out the greatest common factor first. 2 times x squared plus 7x plus 12. We'll come back to that because we're not done factoring. Let's go ahead and go to this 2x squared plus 18x plus 36. Similarly, it looks like all of those numbers are even, so I know I can take out a 2. 2 times x squared plus 9x plus 18. So I'm not done factoring. I have not factored completely, so I'm going to rewrite everything back over again. So we have x plus 4 times x minus 5. And how should we factor this denominator here? Well, I see we have 12. What factors of 12 that add to 7? That would be 4 and 3. All right, times, I'm going to rewrite my x plus 6 times x minus 6 down here. We're good with that. We have 2 times what times what? Well, we need factors of 18 that add to 9. Is that possible? Factors of 18 that add to 9. Yes, x plus 6 times x plus 3. 6 times 3 is 18. 6 plus 3 is 9. Now we get to the fun part. The fun part is canceling all this stuff out. X plus 4s are in common. The 2's are in common, notice. X plus 3 is in common. X plus 6 is even in common. So what's remaining is just this x minus 5 right here over this x minus 6. All right, moving on. Another problem, 6.5, number 6. Solve the equation. And I want y'all to pay close attention to these instructions. And it tells you and check the solution. It's sort of giving you a little warning. All right, so the problem is a squared over a plus 2 minus 4 over a plus 2 equals a. So again, we have an equation with factors. We want to get rid of factors when we want to get rid of fractions when we have an equation with fractions. So our LCD is a plus 2. Let's multiply both sides by a plus 2. Once we do that, we need to distribute on this left side because we have more than one term, right? So we need to multiply a plus 2 times a squared over a plus 2 first. Notice what will cancel out. Don't scratch it out now. Don't, or else you will think a plus 2 is completely gone. But if you notice here, you have, what I'm saying is if you do this and this, you may think a plus 2 is gone and you don't have to multiply it by this, and that's not true. Okay, so when you multiply a plus 2 times the first thing here, yeah, the a plus 2's do cancel out. You have a squared. I just don't want you to forget that you also have to multiply a plus 2 times 4 over a plus 2. The a plus 2's cancel there. We have 4. And then we need to distribute on the right side. So that's a squared plus 2a. Now notice we do have something to the second power, and you're thinking, oh my goodness, we have a quadratic equation forming. But notice both sides has an a squared. So that means when the equation is kind of balanced like that, we can get rid of the a squares. Basically, we're subtracting a squared from both sides. That's nice. That only leaves us with a -4 equals 2a. We divide by 2 to get a equals -2. However, we do need to check the solution. Why? Notice if we plug -2 back into this problem, so it'll be -2 squared, right, over -2 plus 2, and that's a problem. That is a real big problem. What is the problem? Well, the problem is we have 0 in the denominator, right? There's a 0 in the denominator. That's a problem in math. So it turns out that a does not equal -2. Since that was our only possible solution for this problem and is not the actual solution, then there is no solution to this problem. That -2 does not work. All right, so -2 is extraneous. -2 is therefore extraneous. We came up with something that we thought was the solution, but when we checked our answer, it turns out it was an issue with the denominator. It made the denominator 0, so therefore -2 is extraneous. Say it with me. -2 is extraneous. It's not the actual solution, you guys. It's extraneous. It's just an extra little solution that came up that's really not correct. All right, let's move on to another example in 6.5, but we're going to go with number 15 instead. Solve the equation again and check the solution. So let's try this one more time. We have x over x minus 1 minus 12 over x squared minus x equals -1 over x minus 1. Whenever you can factor the denominators, please factor the denominators. So that is factorable. So you have to factor denominators first, if that's possible. So we have x over x minus 1 minus 12 over. Now x squared minus x is factorable because it has the GCF of x. When you take x out, then you have x minus 1. Always multiply that. Make sure it's right. When you multiply that, you actually will get x squared minus x equals -1 over x minus 1. Now, what is the LCD? If you said the LCD was x times x minus 1, then you are correct and you are on your way to doing a real good job on the final. All right, because you understand LCDs. All right, x times x minus 1. So we're going to multiply both sides by that. And notice on the left side, we have to distribute, meaning we have to multiply that x times x minus 1 times more than just one thing. If we multiply the times x over x minus 1, notice that the x minus 1s will cancel, but you still have that x times x left. All right, the x minus 1s will cancel, but you have x times x left. We'll come back because I normally would have written x squared, but I want to make sure you knew where the x squared was coming from. So we'll have these two left over, x times x. Now, I want you to realize that's like over 1, so you can't cancel the x's out because they have to be on different levels to cancel out. One will have to be in the numerator, the other will have to be in the denominator to cancel. Now let's multiply it times 12 over x times x minus 1. All of it would cancel out and you would just have that 12 remaining in the numerator. And then on the right side, I can scratch out here because there's only one term and I can take out that x minus 1 and what's left is x times -1. So that would be -1x, wouldn't it? Normally, I would not write the 1 there, but I want to make sure you understood you do have to multiply those numerators together. So what is this really? X squared minus 12 equals -x. Here we go again. A quadratic is forming. Quadratic equation. All right, so that means we need to pull everything on one side. Let's add the x. We have x squared plus x minus 12 equals 0. Always write everything in descending order. Next up is to factor. This time we are able to factor this equation. Now, if you could not factor it, what would have been your next thought? Don't just say, oh, I can't factor it. That's the end of the problem. That's not true. It is a quadratic equation. Therefore, it can be solved by other methods. Okay. So, again, you need to think about the quadratic formula or another method. So here, since it's factorable, I think that's the easiest way. So I know that we need factors of negative 12 that adds to positive 1. What do you think they are? Well, negative 3 and positive 4, because that positive 4 will allow us to have that positive 1 there. So x minus 3 equals 0, or x plus 4 equals 0, x equals 3, x equals negative 4. All right. But we need to check, right? If we plug 3 back into the problem, will there be an issue? 3 minus 1 up here. Nope, that wouldn't be an issue. If we plugged in 3 into these x's right here, would that be an issue? Nope. If we plugged in negative 4 into our equation, our problem, would that be an issue? No. Notice that there would have been an issue if our answer, I'm setting the denominator to 0 to see what would have been the restrictions. So the restrictions would have been x equals 1 or x equals 0, because we already figured out is x equals 1. All right, so these are the restrictions over here. And since we didn't get 1 or 0, we're good. 3 and negative 4 are the actual solutions, guys. Actual solutions to this problem. Both were the actual solutions to the problem. Now, what would have been an issue is if our denominator was x minus 3, for example, and then we try to plug in the 3. And that would have been an issue, for example, or if it was x plus 4. Let's move on, though. So for Weber sign, I noticed when it asks you for the extraneous solutions, and me write this, extraneous solutions. All right, so make sure you write these notes and study it. There are none here. Okay, there are none here, but in Weber sign, say this, in Weber sign, none here. I'm putting none. I want them to put none in Weber sign, but Weber sign asks you to type. What do y'all think I'm gonna say? They want you to type no solution. I don't get that. I complained about it. I am a mathematician. I kind of know what I'm talking about. It's very confusing, and you all are confused by that no solution. I'd rather them have put none as what you should type. There are no extraneous solutions, but they want you to put in there no solution, which doesn't make sense to me. But I'm just a mathematician. I just, moving on. Let's go on to this problem someone posed to, I don't know which section it is, guys. I don't think she said it, but it's 2 times radical 5x cubed y times 3 times radical 35x y squared. What I would do personally is go ahead and multiply everything that's on the outside together, right? So 2 times 3, 6. Bam, already we're halfway done. And then multiply everything that's in the radical together. All right, and keep it on the radical. 5 times 35. What is that? Let's go with 175. What is x cubed times x? That's x to the 4th. What is y times y squared? That's y cubed. But we can't have anything under the radical that's kind of like, you know, if you can find the square root of it, you have to simplify it, right? Or if there are perfect squares under the radical, because this is a square root symbol, then we have to get rid of it. So give yourself a little space. Well, let's break it down. Let's break down this 175. Is there a perfect square in 175? Perfect square. So I want you to try it, and it might be best to pause the video if you are working through the problems along with me. All right, so hopefully you got to 25 times 7, and of course x to the 4th is a perfect square, so I could just say square root of x to the 4th is x squared and take the x squared out, but I'm going to break it down to perfect squares. I'm going to break down this y cubed into as many y squares as possible, and then give yourself some space because we're going to take some things out of this radical. Let's look at this square root of 25. All right, so square root of 25 is 5. We're going to take that out. Okay, but the 7 stays under because there's no, we already broken down that 175. There is no perfect square in 7. The square root of x squared is x. The square root of x squared again is another x. Square root of y squared is y. And of course we're multiplying everything on the outside later. And then y, we don't have enough on the end here, so we just keep that y there. That's that y here. So if we multiply everything over here, it looks like we have 30 x squared y times the square root of 7y. All right, let's move on to maybe two more problems, and we'll be done. Someone had an issue with this problem here, and I almost skipped it, but I thought maybe I need to explain. If you are factoring a problem like this, the best thing you need to do first is to put it in descending order. So that would probably be my best tip here, is to put it in descending order, or it will look unfamiliar and you're just going to be totally thrown off that your terms are not in order. Now once you see that your terms are in order, then you realize this is a trinomial and it's factorable. Notice that all of these numbers are factorable, so I already know I can factor out a 2, because if it's even, those numbers are even, then you can factor out a 2. But there's actually a greater common factor. Let's try 4. Then we have 3x squared minus 13x minus 10. This is where you're going to use the AC method. Again, if you need practice on the AC method, refer back to those videos on the AC method. But I normally can use trial and error. I know that that's a 3x squared, so the only possibilities could be 3x and x. There's no other possibilities other than 3x and x for that. And then I just try to figure out what factors of 10 that will work, so that when we put this all together, we get negative 13x in the end. So I came up with that positive 2 and minus 5. But always multiply everything. Make sure that you do indeed get 3x squared minus 13x minus 10. All right, because there are sometimes other factors that won't work, so you need to make sure they actually do work. All right, I'm going to move on to the next problem, which is 9.6 number 2, and this will be the last one for this session. We have, okay, hold on, square root of negative x plus 4 equals x minus 4. Now we must get rid of this radical. We have an equation, so we can get rid of this radical by multiplying both by squaring both sides. Let me say that, squaring both sides. Now when you square that radical goes away because those are inverses of each other, and you're only going to be left with what's under the radical. However, on the right side, what is x minus 4 squared? What does that mean? Now this is something that hopefully by the end of this course you understand what x minus 4 squared means. There's definitely a misconception about what that means, so hopefully you please get this before the final exam. X minus 4 squared means x minus 4 times x minus 4. Not that shortcut way that some people claim it is. It's not that. Is really x squared minus 4x plus 16. That's what it is. But a lot of students do this shortcut way and it's not right. Alright, so you have to write that twice, those parentheses twice, and you have to FOIL. Alright, so what is it really on the right side? That's x squared minus 8x plus 16. And then since I see a quadratic forming, I'm going to pull everything over to the right side. Since I have my x squared on the right side, it's positive. There's a positive coefficient there already. So I'd rather pull everything to the right side. Let's work. So we're going to add the x since that's a negative x. And we're going to subtract the 4. All right. So when we do that, now on the left side we have 0, x squared. We have this negative 8 plus 1. All right, negative 8 plus 1. That's negative 7x plus 12. All right, we have to factor this trinomial. It is factorable, but again, if it wasn't, you would use the quadratic equation. We have x and x. Factors of 12 that add to negative 7, negative 4, negative 3. So we have x minus 4 equals 0 or x minus 3 equals 0. So that's x equals 4 or x equals 3. But again, when you have radical equations, you have to check radical equations. Okay, we have a radical in our equation, so we always have to check the answer. All right, let's first check x equals 4. When x equals 4, all right, again, what I'm doing is using our equation as a guide. Using our equation as a guide, I'm plugging in 4. So that's negative 4 plus 4 equals, and I'm talking about the original equation, 4 minus 4. So I substituted all of the x's with a 4. And so does the left hand side equal the right hand side? Equal the right hand side? Question. All right, if you look under that radical, we have square root of 0 equals 0. 0 does equal 0. Check. So x equals 4 is an actual solution. We need to do the same for x equals 3. So we have already determined that 4 is good. But what about when x equals 3? So square root of negative 3 plus 4 plus 4, does that equal 3 minus 4? Yes or no? What do you think? So that's the square root of 1 equals negative 1. Square root of 1 is 1. 1 does not equal negative 1. All right. So what does that mean for 3? 3 is not the actual solution. 3 is extraneous. 3 is extraneous. So I hope this tutorial helps you, and I hope you do really well on the final exam.